Okay, so let me invite our first presenter, Miss Jessica Koeswanto. She is a mentee of Professor Gupta. Okay, please give a big hand to her, to our first presenter. Now you can share your presentation.
Good morning, Professor, mentors, Ms. Kim, and everyone here. First, I would like to say thank you for allowing me to present my presentation here. It's an honor to be able to present here. Let me briefly introduce myself. My name is Jessica Koeswanto, and my mentor is Professor Gupta. Today, I am here to talk about wind power. The purpose of this presentation is to know the process, advantages, and disadvantages of wind power as an alternative energy source. My presentation is divided into some parts. There will be history, context, working, advantages, disadvantages, feature, conclusion, and also the references. So I will start with the history of wind energy. People used wind energy to propel boats along the Nile River as early as 5000 BC. By 200 BC, simple wind-powered water pumps were used in China, and windmills with woven red blades were grinding grain in Persia and the Middle East. New ways to use wind energy eventually spread around the world. By the 11th century, people in the Middle East were using wind pumps and windmills extensively for food production. Immigrants from Europe eventually took wind energy technology to the Western Hemisphere. American colonists used windmill to grind grain, pump water, and cut wood at sawmills. Homesteaders and ranchers installed thousands of wind pumps as they settled in the western United States. In the late 1800s and early 1900s, small wind electric generators, or called wind turbines, were also widely used. The number of wind pumps and turbines declined as rural electrification programs in the 1930s extended power lines to most parts and range across the country. However, some ranches still use wind pumps to supply water for livestock. Small wind turbines are becoming more common, mainly to supply the electricity in remote and rural areas. First, what is wind? The wind is the stabilization movement of air between areas of high and low atmospheric pressure, created by the uneven heating of the Earth's surface, such as land, water, and air. The greater the pressure difference between this area, the harder the wind blows. Wind also exists as the circulation of air around a high or low pressure area. And what is wind power or wind energy? Wind power or wind energy describes the process by which the wind is used to generate mechanical power or electricity. Wind turbines convert the kinetic energy in the wind into mechanical power. This mechanical power can be used for specific tasks, such as grinding grain or pumping water, or can be converted into electricity by a generator. Electricity produced is sent to transformer where voltage is increased and sent to the power. A windmill is a wind-powered machine that converts the energy of wind to pump water or grain or mill grains. It uses the power of wind directly and converts it into mechanical energy by means of vanes called sail or blades. A pressure difference is created when the wind blows over the blades, causing the blades to rotate. A windmill captures the wind energy and then uses a generator to convert it to electrical energy. The design of a windmill is an integral part of how efficient it will be. When designing a windmill, one must decide on the size of the turbine and the size of the generator. Windmills are usually used for pumping water and crushing to green rocks and agricultural material. A wind turbine is a mechanical device that converts the kinetic energy of wind to generate large amount of electricity. It is one of the most effective and low-cost sources of renewable energy that use wind power to generate electricity. The blades of a wind turbine operate on the principle of lift and drag, just like airplane wings, commercially used to generate electricity to power homes, school, or business. There are two types of turbines, such as large wind turbines and also small wind turbines. The large turbine, it is able to deliver electricity at a lower cost than a smaller turbine because foundation costs, planning costs, and etc. are independent of size. It is well suited for offshore wind plants. In areas where it is difficult to find site, one large turbine on a tall tower uses the wind extremely efficiently. And this is a small turbines. Its local electrical grids may not be able to handle the large electrical output from a large turbine, so smaller turbines may not economical in some areas. And this is the difference of windmill, large turbine, and small turbines. These are the parts of the wind turbines. They are low speed shaft, rotor blade, gearbox, control electronics, high-speed shaft, and also the generators. Wind power generators convert wind energy to electrical energy. The generator is attached at one end to the wind turbine, which provides mechanical energy. At the other end, the generator is connected to the electrical grid. The generator needs to have a cooling system to make sure there is no overheating. How does a wind turbine work? Wind turbine work on a simple principle. Instead of using electricity to make wind, like a fan, wind turbines use the wind to make electricity. The wind turns the propeller-like blades of a turbine around a rotor, which spin a generator and creates electricity. The wind is a form of solar energy caused by a combination of the concurrent events. First, the sun evenly heating the atmosphere. Second, irregularities of Earth's surface. Third, the rotation of the Earth. Wind flow patterns and speed vary greatly around the United States and are modified by bodies of water, vegetation, and differences in terrain. Humans use this wind flow or motion energy for many purposes. First, for sailing, flying a kite, and even generating electricity. The terms of wind energy and wind power both describe the process by which the wind is used to generate mechanical power or electricity. This mechanical power can be used for specific tasks, such as grinding grain or pumping water. Or a generator can convert this mechanical power into electricity. A wind turbine turns the wind energy into electricity using the aerodynamic force from the rotor blades, which work like an airplane wings or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. The force of the lift is stronger than the drag, and this causes the rotor to spin. The rotor connects to the generator either directly or through a shaft and a series of gears that speed up the rotation and allow for a physically smaller generator. This translation of aerodynamic force to the rotation of a generator creates electricity. Onshore or offshore. So onshore wind is the one that blows from the sea towards the land. On the other hand, offshore wind is the type of wind that blows from the land towards the sea. Now let us see the advantages and disadvantages of onshore and offshore. First, the advantages of onshore. First, its regular onshore turbines last for around 20 years. Second, normally it takes about 2 to 3 months before the wind turbine has paid itself back. Third, this also includes the energy which was used to produce, install, maintain, and remove the wind turbine. Fourth, it is a cheaper foundation. And the last is cheaper integration with electrical grid network. While the disadvantages are the first, wind turbines are noisy. Second, each one can generate the same level of noise as a family car traveling 70 mph. And the last, some people think that the large tower of wind turbines destroy the view of the landscape. Now, the advantages of the offshore. First, an offshore wind turbine is stronger than an onshore turbine. It can last around 20 to 30 years and produces about 50% more energy than onshore turbine. Third, when a strong wind blows, it produces around 3 to 5 MW per hour and the less higher and more constant wind speed. And the disadvantages are more expensive to build and more difficult to maintain and access. And here are the impacts. First, the advantages. Wind energy is free, pure, and renewable, and also the cost of production. Creation of jobs, reduction of fossil fuel consumption, variety of wind turbines, economical benefits, and preservation of natural resources. While the disadvantages are wind unreliability factor, environmental concerns, supply and transport issues, level of production or energy density, petition and protest on wind farm, preservation of natural form, natural security. For the future, 20,000 total turbines installed by 2010, 6% of electricity supplied by 2020, 1.5 until 6 MW per turbine, 60 until 120 meter height, 5 km from shore, 30 meter deep ideal. Gravity foundation, pole or turbine formation. The shaft can act as an artificial drawback steam losses. Underground cables lead to shore and visual action. And for the conclusion, wind power is not 100% friendly to the environment, and a number of arguments have been highlighted to support the point. However, as a pure renewable source of energy having minimal effects on the environment, wind power is the most appropriate source of energy that can be used to replace non-renewable sources of energy such as fossil fuel and coal, which are known to have immense impact on the environment. And here is the references. Thank you very much for listening.
Okay, please give a big hand to our first presenter, and thank you very much for the presentation. So the audience, do you have any question to the wind turbine?
Ask some question, don't let it go that the wind is the good way to think of it. So think of what you might be thinking. So now is a good chance to interact. Maybe I can start, that might open up the more thoughtful thing. So in some slide, you use the term windmill and the others use wind turbine. What's the difference? At least one is right. One is right. You use the windmill, and then the next thing is the wind turbine.
The windmill. The windmill usually the one that have like the blades. Like I think it's different between the blades.
I'm sorry, I don't understand it. What do you mean by windmill? What is windmill?
So windmill is a wind-powered machine that converts the energy of wind to pump water or green or milk waves.
Okay. So the term mill is used, this was used in a former time. Flour or making bread was the big thing, right? So how do you bring the energy to take the grain and make into flour? So that was a mill, right? So the former time, windmills were used for making flour from wheat or something, whatever you want to crush it. So windmill was a good way. You had the rotating shaft underneath the grinder. So that was the way so that was like a mill. Hence the term mill that was used back in 1800, 1900. So that's a windmill. And now we use the wind turbine because it's like a turbine, like a propeller blade, right? So the turbine is the one which gives the lift, and that gives the power, and hence the term wind turbine power, right? So subtle difference, principle is the same, but in one case we grind the wheat or whatever you want to make the flour of. Could be corn, it could be wheat, and the other case we're generating electricity because that's more important commodity. Because once you have the electricity, you can actually make a mill at any location you want. Yeah. Any other questions from anybody else?
May I ask a question about, thank you very much for your presentation. It was really intriguing. I'm kind of interested in wind power, and it was really insightful. I have so much to learn, but I have a question about onshore and offshore wind mills. You mentioned that offshore wind turbines are like more expensive, which I totally understand because you have to build it in the ocean. So I understand, but like, are there any technologies or something that's like being studied to overcome like those obstacles and like make it more easier to build offshore wind turbines?
I'm sure Jessica can answer that.
And that's what
So maybe I can help Jessica because that's not. If you look at the basic principle, both are exactly the same, right? It's there's no difference between onshore and offshore. The only difference is when you look at the offshore, which means you're going into the water and below the surface of the water. So you need to have a pole which is very heavy, very structurally very rigid. So when the ocean current comes in, it doesn't get demolished. So it really is a mechanical problem as opposed to anything else. So that putting a post, which is several tons or tens of tons or hundreds of tons, that's what you need to erect it. So once it's in place, it can, it's a mechanical thing. It's nothing, there's no problem with the technology. Technology is there. It's just a matter of getting all that big post, big heavy thing, and getting it under the ocean bed, and then erecting it from ground up or ocean surface up. So that's one part. The second is, why do you want to go into the ocean, right? That's a related thing. So the reason why you want to go to the ocean is because if you look at the wind, is basically the temperature difference between the surface, which is surface being the ground level, i.e. from land going to the water. So ground temperature, it changes very drastically. Daytime might have For example, I don't know, 30 degrees centigrade, and in the nighttime it might drop to 10 or 15 degrees centigrade. Whereas if you look at the ocean temperature, it doesn't change much. So you have a big driving force going from high temperature to low temperature, and then the reverse is true when you get up in the morning. So it actually gives you a high wind. And this is one reason why the wind power from the offshore is much more, because you're getting that much more wind. And so you can design the blade and the turbine to get the maximum out of that at that location.
Thank you very much. May I ask one more question then? So I think offshore wind turbines are like more effective and like using like the wind power. Do you think that as like the world shifts to using like renewable energy, like onshore wind turbines would maybe stop and be replaced, or like everything would be replaced by offshore turbines? Do you think like that could happen?
Jessica, do you want to answer it? I think you're muted. Jessica, did you get the question? Maybe if not, you can repeat the question again because she didn't hear it.
So like, because offshore wind turbines are more effective in using the power, do you think that in fact it's better for all, like many of the wind powers to be replaced by offshore wind turbines in the future? Or is there anything that you think that can only be achieved by onshore wind turbines that makes offshore, that stops like the replacement?
Did you get that, Jessica, the question?
I think it seems she has a network problem that she's somehow frozen and then
Yeah, no problem. I can answer this very briefly. So I think the offshore wind is, of course, you're getting more, but the cost is more. And the trend to go to offshore, it's a good one, but the problem is the costs are high. But the advantages are you have no aesthetics problem. Everything is beautiful because it's far away from the scene. You don't have any problem of birds running into the wind turbine. You don't have a noise problem as you see it on the land. But the contrary part of that is the costs are high. Maintenance, if you see it, that's becomes a major challenge if something happens. Hurricane, tornadoes, twisters, they come, they can damage it. But certainly the trend is to go to so-called the shallow waters, but offshore, maybe half a mile, 1 mile, 2 miles away. And that's trend certainly continues to harvest the energy because it's more wind there, more effective, but keeping in mind that it's more costly.
Thank you very much.